I'd like to deal with forces acting on structures. So just to review, we've looked at the force of weight or gravity, and we know how it's different than mass. But we can draw out forces to see whether they're balanced or unbalanced acting on a structure. So in general, what is a force again? Well, a force can be a push or a pull in any direction. It's usually invisible. We can't see it. We can see the result of it, but we can't see the force. And it comes in different forms. In physics, we often might use drawings to help identify what's happening on an object, or in the case of engineering, on a structure. And we call these arrows special names. Sorry about that, they're called vectors. Let me get this. There we go. So in physics, a vector means an arrow with a certain direction as well as to represent a force, as well as a certain length, so a direction and a length that represents the strength of the force. We call that the magnitude. So length. So here is a force. Someone's probably pushing on the box this way. Notice the length of the arrow, and we can give it a quantity, let's say 10 newtons. And let's say another force vector, which is this arrow in the opposite direction. Again, notice the length, 10 newtons. If they're both 10 newtons, then they should be the same length. The only thing different about them is they're acting in opposite directions. And we should be able to predict then what might happen to this box if those two forces were acting on it. What do you think would happen? It would be nothing. No movement. The forces cancel out. So no movement. So let's talk more about that. The direction of the push or a pull on an object and the size of a force is measured in newtons. So it could be a pulling force like this arrow, or a pushing force like this arrow. Sometimes we can combine forces. So let's say one arrow and another arrow are both pushing on the box in the same direction. If that's the case, then we would add the size of the forces to get what's called a net force. So let's say, for example, force 1 was 15 newtons and force 2 was 20 newtons on the box. What would the net force be? Well, the net force would, we take the arrows, we can line them up. 15 and 25 would mean one great big long arrow, or 15 and 20, one great big long arrow would represent the net force, which is 35 newtons. 15 plus 20. So that's what the net force would be, 35 newtons. Now we have to mention the direction, to the right. However, sometimes forces act in opposite directions to each other. And if that's the case, then we would subtract the two forces. So here would be our formula, force 1 minus force 2. So let's say force 1 was 20 newtons in this direction, and force 2 was 15 newtons in this direction. What would the net force be? Well, this would cancel, so all we'd have left would be that little bit. And in which direction? This direction. So we would say the net force is a tiny little arrow like this, 5 newtons, and it would be to the right if our original arrow was 20 newtons to the right. So 20 minus 15, 5 newtons to the right. So forces are in balance if the net force is equal to 0 on a structure and forces are unbalanced if the net force isn't. Now, don't forget, motion will occur in objects if the forces are unbalanced, and we don't want this. No, when it comes to structures, we want forces to be balanced for structures. Otherwise, they might fall apart. Let's look at this. What would the net or resultant force be if these were our two forces? 15 in this direction and 10 in this. Well, we could bring this arrow over and line it up. The 10 newtons right there. And so that would cancel that part. So all we'd have left is 5 newtons to the right. The resultant or net force would be 5 newtons to the right. So how does this equate to structures? Well, let's say you're building a bridge and you need to know what the maximum weight or load the bridge could hold before it collapsed. Well, an engineer would test the bridge and subject it to various forces to come up with this idea. Let's look at this quick website to get you to practice finding the net force. So let's start it. We have 3 dogs here, 2 dogs here, we have 3 dogs pulling backwards here and 3 here. So let's figure out the net force here. Well, these 3 dogs are pulling back this way, but these 3 are pulling back this way. So they're going to cancel each other. No movement horizontally, no movement left to right. We have 2 dogs down, but 3 dogs up. They don't cancel, and so we're going to get movement going upward, I guess. So I'm going to move the balloon right here because that's where I think the net force is. Yay! Okay, let's look. 2 dogs here, 1 here. So the stronger force is going this way, so I would guess that it's going to be pulled probably right about there. 3 dogs, 1 dog. Whoa! There's going to be a strong pull towards this direction. 3 dogs, no dogs, and a strong pull up. So it's going to be probably right there. Same idea, we already looked at that, so let's put that there. Whoa, here's a hard one. 3 and 2, so it's going to go upward, and 3 and 2, and this way. The net force is going to be right there. 3 and 1, so it's going to go down, and 2 down and over. Oops, just missed it. 3 and 3, 3 and 1, so it's going to go this way and up. Yay. So that gives you a good idea of force vectors and trying to figure out the net force acting on a structure. Hope you enjoyed it.